Hi everyone, Krishna this side, and in this video I'll be covering this path with minimum effort problem from the LeetCode. So it is problem 1631 from the LeetCode, and let's look into this problem statement first. So you are a hiker preparing for upcoming hike. You are given heights a 2D array of size row cross columns, and height of row call represents height of cell row call. You are situated in a top flat 0 comma 0 in this particular cell we are been right now, and you hope to travel to bottom right cell. So we just wanted to reach to this particular location from top. So we can move up, down, left, right, any direction we want, and we just need to get the minimum efforts that require. So what is the minimum efforts they are saying? A route's effort is a maximum absolute difference in heights between two consecutive cells of the route. Return the minimum effort required to travel from the top to bottom of the cell. Okay, so what they are saying is we are actually at this particular location and we want to reach to this. So we want to explore all the path, and we need to get the absolute maximum difference, and in whichever the path that we explore, if the absolute max difference is minimum, that is something what we need to return at the end. So if we look into this particular example, the absolute difference between 3 and 1 is 2, 3 and 5 is 2, 5 and 3 is 2, and 3 and 5 is 2. So whatever the distance that we covered from this particular path, the maximum distance that we got so far is 2. So the answer from this particular path is 2. If same goes from this particular path, if we look into this particular one, this absolute difference is 1, here it is 0, but so far we got maximum difference as 1, right? So till this path the absolute difference maximum that we received is 1. Again from here it is 0. So if I want to explore this path, the maximum difference that we got from this particular path till now here is 1, but here it is 3, right? So whatever the distance that we covered, but at the end it is getting 3. So definitely this particular path is getting 3 as maximum absolute difference, right? But from here we are getting 2. So of course this is the best way we can reach here. Even if we can try to explore any other path, any other route, we end up getting this route as a best answer. Okay, so here also if we look into this particular example third, if we follow this particular path, right, we will be getting 0 as maximum of absolute difference. So this is the best route that we can cover, and at the end we just need to return the maximum absolute difference that we got from following that particular path. Okay, so yeah, we can explore all the four directions. If we look here, as in it is mentioned in the problem statement as well, we can go up, down, left, right to get the maximum absolute difference. How to approach this particular problem, right? So if we take this particular example for our understanding, what we need to do is we need to maintain another separate array where we can track the absolute difference, the maximum absolute difference we got so far by exploring different paths to reach that particular node. Okay, to reach the this particular cell 8, we can come from here, we can come here, from here we can even come from here, even we can follow this particular path as well. So there are lot many paths which through which we can reach to this particular cell, right? So yes, all those paths we try to explore, and for that we can use the priority queue. Okay, so at any particular cell we will maintain another array. Okay, so at 0th location it will be 0 absolute. That's the answer that we will be going to return, right? If there is only one cell and we are actually at that particular cell, so the answer is going to be 0. So by default at 0th index the answer will be 0. So dp array is what I wanted to maintain here, and rest all cells we will currently fill it with the maximum value that we get from the integer. Okay, so int max or till, that is something what we will fill here in all the rest of the cells. Okay, so now we will start from the 0, and this particular cell we will put it into the priority queue. So we can use priority queue or any other data structure as well, but the best is the priority queue. Okay, so with the priority queue we can get the minimum distances that are available so far that we are trying to explore. So for this type of problems the best is the priority queue, because we are trying to explore all different paths, cells from current cell. Okay, so yes, priority key is the best approach for this particular type of problems. Okay, so in the priority queue, what we will do is we can create another class and have the row, column, and absolute difference, these three fields in there, as well as we can have even an integer array which will be having three values of row, col, and absolute difference. So initially we will fill the priority queue 0 as row, because we are starting from the 0th row, 0th call, and the absolute difference is by default 0, as in we are starting from here. Okay, now we will start exploring to the four direction of this priority queue. We will pull out whatever the data that are available in the priority queue, and we will explore all the four different directions that we can achieve from this current row and call. Okay, so currently it is 0 comma 0. From this one, we if we try to go left side or even on the top, we cannot go right, because that is going to be out of bound. So we only have the cells that we can reach from here is the bottom one and the right side of this particular cell. So we will check first in the left right side, we check that what is the absolute difference. So from here, if we start going this side, so the absolute difference from that is we will be receiving 1. And in this particular cell, it is currently infinite. So what we can do is we will update this dp with 1, because that is the maximum absolute difference that we got. And even if we look here, the absolute difference here is okay, once we get the absolute difference, we can put that into the priority queue as well. Okay, so by default this is what available in the priority queue, we pull that out, so this is not available now in the priority queue. But the new one that we got is 0 comma 1 is the column, and what is the absolute difference, it is 1, right? So that is available in the priority queue. Again, we are trying to explore this node as well. So this particular direction, so what is the absolute difference, it is 2, right? So what is the row, it is 1, and the column is sorry, it is 0, and the absolute difference is 2. So based on the absolute distance that we have, the minimum absolute distance, the priority queue, we will sort it. Okay, so based on the minimum distance that we get, we will put it in the priority queue at the top. So that is the priority that we will be provided to this priority queue. Okay, now this is something what it is, and this absolute difference will also get updated because it has the maximum value currently, and the 2 is minimum. So whatever the minimum value we get so far by exploring the node, that is something what we will be updating in those nodes, in those cells. Okay, sorry for that. Okay, now once these two are available, we will again pull the topmost priority queue element that we have. And we have 0 comma 1, so we are currently at this particular cell. So we will start exploring in four directions. So from here we can achieve only three cells, this one, and this one. So from here, if I try to go here, so the absolute difference is 1, but currently it was 0, right? So at any point in time, if we get the minimum absolute difference available in the dp array, then we simply continue from there. So we don't want to revisit there, because it has the maximum maximum absolute difference that is already available. Okay, the minimum answer that we need to get. So again, we don't want to go there because it has already 0 as in the best answer, and we are getting 1, right? So we don't need to go there. From here to here, it is again we are getting 1 as an absolute difference. Okay, and currently it is the absolute difference is 1. So we will check whether the current as in we are following the path, so we need to get maximum answer. Okay, so whatever the current absolute difference we have at this particular cell is 1, right? And from here to here we are again getting 1. So we will check whether this one or this one, whichever the maximum that we get, we will fill it out here. Because of course, by following this particular path, there would be any particular location where the maximum absolute difference we get, but at the end it could be minimum only. So we need to track the maximum difference that we get by following this particular path. Okay, so we will compare this one with the current absolute difference that we are getting between these two cells. Okay, so whatever the maximum is there, that will be get filled with the dp array. So currently dp is having the maximum one, that is infinite. So the latest whatever we are getting, it is been minimum, right? Between these two, it is minimum. So that is something what we need to fill into the dp array. So same this one is now done. Again, we can follow this path as well. So here, from here to here, it is 6, and currently it was 1. So what is the maximum one? 6 is the maximum, right? So between 1 and 6, 6 is the maximum, and currently it is infinite. So 6 is what we will be filling it right over here. Okay, from 2 we explore all of them, so we can remove that particular row call. And of course we are supposed to fill those nodes as well into the priority queue, okay, by exploring them. So from 3 to 3, it is like 0, 2, and the absolute difference was 1. So this will be available at the top, okay, because it has the minimum absolute difference. So in the priority queue, it will automatically fill that whatever the max minimum absolute difference that we got, that will be available at the top. Okay, from here to here it is 6, so that will be available into the priority queue. So what is the minimum difference? So from 2 to 6, it is like 1 comma 1, that is the row call, and the absolute difference we got is 6. Okay, so that is what we got. From 3 again, whatever the topmost priority queue that data available, we will pull out. So this will get pulled out, and we start exploring the adjacent node. So from here to here, if we look, it is 1, and it has already 1, so we don't need to revisit again. Okay, so we can simply continue from there. And if we look from here to here, it is again 1, and that currently it is having infinite. So maximum absolute difference here till here it is 1. So of course this will get filled with 1 only, and that will get added into the priority queue. So this is right now in a removing state. We will remove it until all the nodes of all the artisan cells and all will get removed. Okay, until we explore all the artisan nodes, we will be having that one, because we pulled out from the priority queue. Okay, so currently new data that entry will get added here is 1 comma 2, and the absolute difference that we got is 1. Okay, this is in removing state. So any other nodes that possibly we can explore, no, right? So this will get removed. Okay, because that is something what we are doing, right? We are pulling the data that is available at the top, and we will explore the adjacent cells in all the 4 directions, and we try to fill the data. From 4, we can go here, we can go here, and we can come downside, right? If we start exploring this side, so it is 4, and already by default it is having 6 as maximum answer. So of course if we go from here to here, it is getting minimum answer. So what we can do is we will update this one with 4, and that entry will get added at right over here. So what is that? It is like 1 1, and then the 4 is what it will be having. Okay, so it will get filled right over here, because based on the absolute difference, the priority key has been available, right? So yeah, that's all. And then we can explore from here to here, but it is already having that minimum distance, so we don't need to go there. But in the downside, if we look here, so what is the minimum difference that we are getting? It is 1, and maximum absolute difference so far here it's 1 only, because that's how we are doing it right now. So it will be like 2 2, and absolute difference is 1. Okay, and here also we will fill it with 1. Okay, and now this one will get removed, because we explore all the path. Whatever the left out data that is available here is at the top is this one. So we check every time we check, right? If the moment we got in the priority the row, the last cell, because 2 comma 2 is going to be the last cell, right? So the moment we reach to the last cell, we definitely got the minimum answer, right? Because we are trying to get the minimum answer from all the possible routes, and at the moment we get that cell available into the priority queue, definitely that is going to be the minimum answer, no doubt, right? Because if we remove this one, of course downside has the this type of answers, right? And that is not going to give us the minimum answer further going ahead, right? So the moment we saw that row and call is going to be the last cell that we want to explore, we will simply return that absolute difference. That's how we will deal with this one. Okay, so that is how we will do it. Let me write the code as well. Let me get the row from this one. Heights of heights dot length, and column is going to be heights of 0 dot length. Okay, now I will create a DP array as I said, and it will be having size row cross call. Okay, and let's fill this DP array with the maximum values. Okay, this is two-dimensional array, right? So we need to use streams. Arrays dot stream dp dot for each a arrays dot fill. I'm just trying to avoid writing that to for loop, and instead of that, I'm directly using the stream API to fill the array. Okay, so all the cells will get filled with the integer dot max value. Okay, So it is been filled. Now DP of 0 is of course going to be 0, as I already said you guys. So it is been filled with 0. So we created the DP array. Now what next, right? We need priority queue. In the priority queue, I will just maintain here integer of arrays and PQ. So new here what we will do is with this whatever the what I'll do is in this integer array, the last cell will be absolute difference. Okay. So based on the last cell, I'll sort this data. Okay. So we have sorted that, and I'll fill this priority queue with 0 as a row, 0 as call, and 0 as a distance, because we are currently started with 0th cell. Okay, so the priority key is also filled. Now what we will do is we'll start getting the data out from the priority queue, and we'll explore all the adjacent cells that are available in the all four directions. Okay, we get that priority queue if, until it is empty. Let's pull the current data at the top that is available in the priority queue. pq dot pull. Okay, and the row is going to be 0th from this current, and call is going to be current of 1, and abs absolute difference is going to be current of 2. Okay, these are the three values that will be available into this my integer array. That's what I said also. Okay, so now we get this data from the priority queue. The first thing that we'll check is if absolute distance this is greater than dp of row comma call. If that is the case, then we will simply continue, because we got the best answer in this dp array, right? If any absolute difference that we are getting here, let us suppose I was doing with this all the right at the last we got that answer. So simply that is the condition that I'm going to put here. If the row and call is going to be the last one, what I'm trying to say is if row equals row minus 1, and c equals call minus 1, because these row and call are what I have defined. Okay, so if that is the case, we simply return the absolute distance that we got, because that is going to the minimum absolute difference that so far we got from by exploring particular path. Okay, so that is that particular case defines, and this condition defines that if at any point, see here it was 6, right, previously. Now we got 4, but by exploring any other path from here, if we start exploring, right, it will be we will get 5. So already it is having in the dp array, it is having the minimum answer, right? The 4 is what we have. Then why we need to add the 5, right? So we simply continue from there, because that anyway that particular path is not going to give us the best answer, right? So we will simply continue from there. We just pull that data. We will see that if this particular path is not giving best answer, we will simply continue and we pull next data from the priority queue. Okay, for that this condition was there. Now once I do this two if conditions, so what next, right? So we will we require to look into the four different directions, right? All the four directions. Let us suppose from at this particular 8, we are actually now the row and call we are denoting at this particular location. Then what we can do is we will start exploring the four direction of this particular. So what I'll do is I'll simply create a this particular dies. Okay, this two-dimensional which will help us to explore in all the four directions. Okay, so 1 comma 0, these are like we will simply add it into the uh, new row and new call. This will help us to get the new row and new call. Okay, this 0 comma minus 1 defines the this one. Okay, we are going one this 0 is actually denoting row and 1 is actually denoting column. Okay, so all these values fields defines that way only. Okay, so last one is going to be minus 1 comma 0. We can fill this type of directories. Okay, so these directions will help us to easily add the current row into the current row and current call column. We will add these values and we can easily get the above column, above row, sorry, the left side of the cell, right side of the cell, bottom side of the cell. Okay, easily we can get those values by adding them simply into this row and call. So currently we are at let us suppose at this one, the row and call is currently 1 and 1. So if we add 0 and minus 1 into that this row and call, it will simply give this particular one. If we look into this one, this will give give us this one. Okay, we are moving ahead, and if we look into this one, this will give us we are currently at the same row, but column is getting incremented because we are adding this one into the column, right? The row is same. Sorry, the row is same, the column is getting incremented because here, so this particular one cell will give us this one. Okay, so that, like that way, we will keep on adding these values into this row and call, and we will explore all those paths. Okay, so what I'll do is I'll run into the four directions. This will be like this, and then what I'll do is I'll simply get new row. Let me define as new row, director of 0, and new call equals director of 1. Okay, so we got this new row and new call. That will be in four directions we are trying to explore, and we need to check right now if we are at this particular cell, this new row, if we add this any of the it will go out of this bond, right? So we need to check that this new row and new call are in a particular bond. So this should be less than or equals to 0, and new r should be sorry, this should be greater than or equals to 0, and this should be less than row, and then again we check with the call as well, greater than or equals to 0, and new call should be less than call. Okay, so these four conditions needs to be validated, then only we will be see that it is actually in a bond. So if it is going outside of the bond, the if condition will not enter into the if condition. Okay, now we once we get that, we will get the absolute difference. Okay, new absolute, new ABS. Okay, in the new ABS absolute difference, what we'll do is we will check that math dot max between the previous absolute difference, absolute distance comma math dot ABS of these two cells distance, if we are actually at looking for this one, and we are tracking from this path, right? So height of new row new call minus heights of r comma car. So the whatever the absolute difference that we get between these and the previous one that we got so far, okay, between them the maximum that we get if we are following this one. Let us suppose here we got the maximum distance, but this particular path is giving the best answer, and here it is 0, but by following this path, this was the maximum absolute difference that we got, right? So of course for this one also, that maximum absolute difference is what we will maintain at every point in time. So this is the new absolute difference that we got. Now we check that if this new absolute distance is actually less than what we have, right? So in the dp of r and c, if it is less, then only we will proceed further, right? So new absolute difference, if it is less, what we will do is we will simply dp of rc, we will update it, and it will be new abs, and what else, this got updated, and we will simply put it into the priority queue, pq dot add or offer the new. So it should be new row new call. Okay, new row new call, in that particular we are adding, so new int here into this one, new row will be added into the priority queue, new call, sorry, new call, and new absolute difference. Okay, this is what get added into the priority queue, so we are keep on adding them. Okay, the moment we satisfy with this particular condition, if that is not falling in there, so we will update the tp as well as the priority queue. Okay, so simply this should give us the answer, and at the end we will simply return, let us suppose at the end, sorry, return dp of row minus 1 call minus 1. Okay, so that's what we need to return. Let me run the code. Okay, new int. Okay, sorry, is there any other error? Okay, okay, what is wrong with this one? dp dot for each a, for each a, what was that for each a. No, this is not how it is. For each a, what is symbol a is dp arrays dot stream dp dot for each a. Uh, arrays dot fill. Sorry, this is not how it should be, right? For each a comma. Sorry, I missed, my bad. Arrays dot fill a comma integer, and this is how it should be. Okay, so that was my big blunder that I have done right over here. Okay, all are them getting wrong. Okay, what is that I made mistake here? Okay, it should be if absolute difference is greater, if new absolute is less than dp or comma call mat dot max abs less than dp of sorry. Here it should be new row, new call, right? Then only we are updating these states, right? I hope that should be the mistake I have done. Yeah, let me submit this code as well. Okay, it's been accepted, right? So yeah, that's how we can work on this particular problem. And yeah, if you get the idea or understanding, please make sure to like this video. Thank you for watching this video. Bye bye.